So if you're doing this kind of extracellular recording, one of the things that becomes a critical factor is how large is your signal relative to the background noise. And we talked about filtering a little bit in terms of getting rid of the background noise, and that's one extremely important feature. But other techniques have to be used too. For instance, the electrode amplifier has to be very low noise. You have to use extreme effort in terms of shielding and grounding so that you don't pick up any extraneous noise that way. And you have to make sure that you have a good electrode. Electrodes vary a lot, and those electrodes can go bad, or they can just be the wrong ones from the manufacturer, so forth. And so many subtle things are involved in having a good clean recording where you have a satisfactory signal to noise ratio. One of the tricks you can use, though, is post-processing. So you can take a noisy signal in your computer and run various kinds of algorithms on it to clean up the signal. And one of the techniques that's used a lot is spike sorting. The way spike sorting works is that each of those neurons that your extracellular electrode is picking up has a very slightly different characteristic. It might be slightly different in amplitude. It might have a slightly different wave shape. Those wave shapes come about because the little bit of tissue that the electrical signal is traveling through is not identical in each case. And so the geometry of the signal source relative to the position of the electrode can determine how the signal looks to the electrode. I can sweep through my computer trace the signal with all of these different electrical signals from different neurons, and I can identify a particular wave shape and say, okay, I'm going to sort this composite signal into multiple channels where all the action potentials that match a particular shape show up in one channel, and those that match a different shape show up in another channel. So in principle, I can get more bang for my buck. I can get 3 or 4 neural recordings at once, and those neurons might be doing different things, and that might be really interesting. And it might be particularly interesting, not just because I'm multiplying the efficiency of which I get recordings, but because perhaps I can learn something about the way the nervous system is working by simultaneously seeing how 3 or 4 or 5 neurons respond at the same time to the same signal. For instance, we talked about parallel processing. So let's say that one of those neurons is doing one thing with the information and another neuron is doing a different thing. So I instantly get that information by spike sorting. Now, having said that, it's a bit of a tricky technique, and it doesn't always work all that well. And sometimes you have so much noise that the algorithm fails because it makes hundreds of different channels thinking that you have so many different neurons, but it's just really can't really discriminate one from the next one. But still, it's still a common technique.